Good afternoon. Welcome and thanks for coming. We are Dennis and Insa from TypeFox. And we'd like to tell you about an interesting project we are working on at TypeFox this year, and it is to support the BBJ language and its utilities and libraries with Eclipse Langium. BBJ is short for Business Basic for Java, and BBJ is a Java-based framework for developing business-critical applications. It was created by Basis International, and it is adopted worldwide, for example, in banking, automotive industry, and hotels, for example, by BMW, Mitsubishi, Marriott, Sheraton, Citibank, Amscot, and others. The Eclipse Langium is the language development framework we are using, and it is an open source language engineering tool written in TypeScript and running in Node.js. It has ingrained LSP support, and you can support your languages for Eclipse Theia, web applications, and VS Code, for example, with a harmonious TypeScript-based tool stack. And this leads me to the first hint why we think this project might be worth hearing about. We already heard that the language itself is Java-based, and Eclipse Langium is in TypeScript, and these coexisting worlds are even increased by one, courtesy to the specifics and the history of BBJ. Namely, BBJ was built on the predecessor BBX, which is for Business Basic Extended, and BBX is a scripting language from the BASIC family, extended with a platform-independent interpreter and database. It was first released in 1985, and it has built up a corresponding richness of specific verbs and also libraries, and there are a lot of older projects that depend on BBX, and so we need downward compatibility. In 2001, Basis International introduced the next generation, BBJ. However, let's keep in mind that we still have this basic-like scripting language at the core of the language, and also that we want to keep downward compatibility. Java was added to gain more flexibility, make use of Java's wide range and comprehensive library support, and it was also possible to improve the UI support with Java, and generally gain an object-oriented syntax for BBJ. Two things arise from this that we want to talk about in the remainder of this session. The first one is how we connect the BB part of BBJ to the J part of BBJ, so Business Basic and Java, with Langium in the first place, and this will be the topic of the first chapter of the talk. And afterwards, Dennis will talk about challenges from the different worlds, Business Basic and Java. These challenges can arise from clashes between the language concepts. For example, case insensitivity versus case sensitivity, dynamic versus static typing, and also member call syntax versus qualified name syntax. Also, challenges come from requirements imposed by the added language, like linking for implicit Java imports and also inheritance rules. We are ready now for the first part of detailed explanations, the connection from Java to TypeScript and how it works with Langium. You can see a code snippet here with Java-related syntax in BBJ. You can define a class like you're used to in Java and have fields and a constructor. And what you see here, the variable with a hash mark in front, that's an instance variable. Also, you can define methods for your class. Furthermore, you can import Java types into BBJ. You can do that with a use statement, which is equivalent to the import statement of Java. And for example, you can then use the type for a field you have, and you can also instantiate with a new keyword that was also transported from Java to BBJ. Note that you can also extend a Java class with a BBJ class. And of course, then we have to respect the inheritance rules of Java. For example, we need to make methods and fields of our superclass visible where we need that. So we do not have to calculate only the local scope for a class, but also the actual scope for all the cross-references. But it boils down to one point, where do we get the information of all the available Java classes? We need to pull them from the Java runtime. And we developed a Java interop app for that, dedicated app that gives us the class path information we need. And to get the information on TypeScript side, we communicate with JSON RPC over a socket channel with the RPC protocol LSP4j. The data structure we get from the Java interop app is organized as follows. We can first ask for the load class path, which gets us the additional libraries in the class path, for example, for customer jars or third-party libraries like Guava. Secondly, we can use getClassInfos, and with that, we can get for a certain package that we give as a parameter all classes of this package. And we use that for content assist and also for implicit imports from Java Lang or customer data types. On the innermost level, we can get info for a single class as a parameter, the members of this class for content assist and also for loading of the imported classes for linking. Here's how it works with Langium. We have the Java interop app, and we create a synthetic Langium document and also a Java types grammar for types like Java class, class path, named element, Java method parameter, and so on. And this Java types grammar is loaded via input into the general grammar of BBJ. And we add an AST node for each class to the synthetic document, which we then register to the Langium documents service. There it will be picked up by the indexer to build the global scope. We can do this also with different libraries for different workspace projects. There we need a dedicated token and class loader for each project. And with this, we come to the next part of the talk about challenges of Java and BBJ and how they were addressed. And I hand over to Dennis for this part.
Thank you, Insa. I would like to try out my own remote. Okay. As Insa mentioned before, BASIC and Java are quite different languages. To make them work together, we not only need to extend the syntax, we also need to add some semantics from Java and honor them for sure. We picked up some of cases that were introduced to Business Basic because we think that these are, or this could be also interesting in other Langium projects. Case insensitivity. The host language with its basic-like nature is case insensitive. Here you can see an example of a class definition again, and also some additional code. In BASIC, you can write keywords in any case. Making keyword handling case insensitive is pretty easy in Langium. So each Langium project has a Langium configuration file where you just need to change the property case insensitive to true, and that's all. So the parser and the syntax highlighting works as expected, so it's pretty easy. References. Okay. References are handled in Langium using scopes. So to make scope handling case insensitive, we need to adjust our scope implementation. The Langium scope API allows us to change the behavior of the scope instance by using options. One of the options is called case insensitive, and if you turn it to true, you can reference elements in any case. So it's pretty the same as with keywords. It doesn't? Yeah, now it's working. Sensitive parts of the language comes from Java. These are references to Java classes, to methods and fields. As we refer to Java only through references, we just need to adjust the scoping or the scope computation in this case. So let's look how to do it. First, I would like to explain how scoping works in Langium. Normally, the scope, you can hear me? Oh. Normally, the scope is built by combining different scopes. Starting with the most inner scope, and my example is a method body, where you can access local variables and parameters. Then this scope is wrapped in more wider scope. Here a class scope, where you can access own class members or maybe accessible members of the superclass. The outermost scope is a global scope. Here you normally can refer to public Java classes, or in case of PBX, to some built-in scalar functions. Regarding our mixed scope problem, let's take a global scope as example. As you can see, here we have a reference to type string from Java and to a built-in function message box. The one is case sensitive, the other is not. With Langium, it's again pretty easy to achieve, because the default stream scope implementation allows us to configure each scope instance separately. So we built up the global scope by combining two instances of stream scope. One is configured to be case aware, and the other is not. Important in this case is to first look up the Java scope, because in case of name conflicts, you can still use another case to reference a basic function, for example. So the same trick we can apply on the inner scope if necessary. Qualified name syntax. Adding Java to BBX also added new language constructs such as qualified name syntax. With a fully qualified name, you can refer to a type or to a class by its full name, for example, in a use statement. The syntax here is a dot-separated list of IDs. It is handled as a data type rule normally, and in fact it's just a string. But in Java util date could theoretically, but also practically be a member call. Imagine you have a variable Java, and this variable has a property which is called util, and then the util has a property date. Yeah, theoretically it is possible. So we have a possible conflicting case here. Normally it is not a problem, because places where we are using qualified names normally can be good distinguished. Here is a use statement and a new constructor call. So the parser can see the prepended keyword and decide which rule to apply here. But normally we do this in the grammar. But there are also cases like expression statement, where the syntax becomes ambiguous. Here we have a fully qualified name access to type date and a member call parse. A simple solution to work around this problem is to say let's handle qualified names as member calls for the expression statement. The difference to the qualified name is that in the member call, each segment is a cross-reference and not just an ID. So in this case, the linker would ask us for a symbol named Java, but this is currently not in our scope. The solution. As Insa mentioned before, we created a synthetic Langium document that contains all the classes we loaded from the class path. They then are processed and we get the index information so we can refer to them. What we can do is creating a new kind of definitions, package definitions for each top level package. Like, I don't know, Java, org, or whatever else. Then for each top level package, we again create sub-packages and add them as children. And in sub-packages, we can refer to already existing classes. So when the linker then asks for a symbol with name Java, we could give him a package definition description. And for the subsequent calls, member calls like util, we just look up sub-packages in this top-level package. And finally, we can, for the date, return the actual class we are looking for. All subsequent member calls are working the same as before, because we are referring to the date class now. Yeah, that's basically it. Another challenge arises from the differing type systems. As we said in the introduction, the host language is dynamically typed, while Java is statically typed. Why is the type information important? First of all, type validation or type checking. We would like to validate if, for example, an assignment is a valid one in sense of type compatibility. Content assist, we would like to give good and valid proposals for member calls, but this is not possible if the receiver type is not known. And last but not least, linking. As an example, in case of method overloading, the actual target method depends on the parameter type. And if you don't know the type, you cannot link to it. One partial solution that is in use also since BBX is variable name suffix. There are three of them. $sign marks a variable as a string type, a $sign an int type, an exclamation mark marks an object, and missing suffix means this variable is of some floating point type. So any attempt to assign a value to, for example, an int-typed variable with a string will end up in an error. This works well, but in case of objects, it doesn't really help because we have different objects. Imagine you have button and label, both are objects but are not compatible or assignable. To improve this type checking for object-typed variables, a new verb or statement declare was introduced. User now can explicitly declare the type of their variable. Declare verb introduces type safety to BBJ and allows detection of incompatible assignments at compile time. The downside of that is that it doesn't work for existing or old projects, and also in new projects it is not required to declare a variable before using it. Another possibility to compute a type is to infer it using static analysis. Here are a couple of examples I wrote to describe it. In the first example, a variable myButton is not declared, but assigned with a new button instance. So in the next line, we could assume that this variable is now a button and can provide a better content assist by suggesting only members which are accessible for this particular type. And also we can check if the assignment is valid or not. Oh, sorry. If the member called press is valid, if this method exists in type button. There are some other places where we can safely infer a type. For example, if we assign a return value of the cast function. This is a built-in function which works the same as a cast expression in Java. So here we can also be sure that our variable will be of type a button, or it will just fail earlier, probably with a cast exception. Once we know a type, we can also propagate it to other variables or somehow reuse it to further type computations. Using static analysis helps to find the type of variable, but it doesn't work in all cases. The snippet on the slide is valid, even though the variable, some variable, is not declared or defined. Here we cannot validate the type, or we cannot validate if the assignment is valid or not. This is a common case in BASIC to use an undefined variable, because this snippet could be a part of a document which is a subroutine, where later on the main routine will call this file or this subroutine, and in the main routine there could be some variable declared and even initialized, but it doesn't help us in this context. The second one is generics information. So in BBJ, generics are not available or supported for different reasons. So we are almost on the state of Java 4, so before Java 5. It is possible to derive an element type, but it's really complicated, and in most cases doesn't really work. So in this case, we need to assume that our element will be of type object. The type is not clear here. And finally, all the runtime dependent information cannot be analyzed. Here in the snippet, the taken conditional branch depends on the runtime value. So for the variable fruit, we cannot infer the concrete type again. As a conclusion, it is possible to do a lot in the IDE to assist the user when working with a dynamically typed language, but still there are situations where it is simply not possible. In the last topic of this section, I would like to talk about implicit imports and how it can be implemented in Langium. What is an implicit import? Implicit import means a possibility to refer to a type by its simple name without explicitly importing it into your program. Before starting, it is important to get a raw overview about the Langium index and how it works. So when the Langium language server starts, an initial workspace build is also performed. One of the main tasks of the build is creating an index for all the language documents you have in the workspace. During the indexing phase, for each IST node inside the document, a description is created. An IST node is, for example, a class definition in your document or a method definition inside the class, and so on. Using this information, forgot. The node description itself holds the information about the node, like the name, the document URI, and also the path inside the abstract syntax tree. Index service provides an API that allows us to look up descriptions by name. Using the information from the description then allows us to load the actual document and link to the particular IST node. In the default Langium implementation, the index represents the global scope, so what is globally visible. Now back to Java. Java class descriptions from the synthetic document we told you about before are collected the same way. The document we created programmatically is processed during the build. And if in the document you have a class definition with the name Java lang string, a corresponding IST node description is created. And this description is automatically available in the global scope with this full name, so you can easily link to it in, for example, in a use statement. In some cases, for Java, it's a Java lang package. For BBJ, there are different framework libraries. We would like to refer to types by their simple name and not a full name or through imports. The simplest solution for this DSL is just to add an additional class definition to already existing synthetic document. We just, when we are creating a new class definition and see the package name is matching our implicitly imported package, we just create a copy of this class, but set the name to the simple name. All the work is then done by Langium. So Langium would create again a IST description, and this would be then with a simple name. So then we can just call, for example, new string without importing it. And another way to add implicit imports, and this is also the recommended way to do it for the most DSL, Langium DSLs, is to extend the scope computation service implementation. In particular, the export node function. Export node function is responsible for creating node description for a given node. Luckily, the API allows us to give more than one description back, so a list of descriptions. What we can do then is calling the super implementation, which gives us a description with a fully qualified name, create a copy, set the name to a simple name, and the rest works as in previous slide. So we can reference to your classes by simple name. Yeah, as a conclusion, it's pretty easy to work with implicit import in Langium. So now back to Insa.
As you can see, we have come to the conclusion part of our talk. And we saw that it is possible to connect the business basic part to Java with the help of Langium and a Java interop app, giving us all the information we need about additional libraries and packages and the classes and their specifics for content assist and linking. And we also saw that it was possible to face the challenges of the clashing language concepts of business basic and Java with Langium, and to offer also linking for special cases, and even a fair amount of type checking is possible, however naturally limited by the dynamic typing characteristic of business basic. Note that the project is still ongoing. However, the customer has already published a VS Code extension on the marketplace, which is currently under practical testing. With that, we have reached the end of our talk. Thank you very much for listening. If you have questions, please ask them now or visit us at our booth. It's directly out the door. Thank you.
Thank you, Insa. Any questions?
Why do the postfix for the type hint,
Yes.
$sign and the $sign, why do they repeat again and again? Language, isn't it sufficient to have it once on declaration?
You can have 3 different variables called name that have different suffixes. So you can have name as a string, you can have name as an int.
Okay,
And it also, yeah, this is also the part of the ID. So if you link to it, you need to use a suffix.
It makes sense to repeat the question because it doesn't end up.
Oh, true. Where is the mic? So, okay. The question was why we need to repeat the suffix when referring to a variable with a suffix. The reason is that it's part of the ID, and yeah, otherwise we cannot link to it.
So with the similarities in names, namespacing, are there tools to really support you with finding the correct constructs, especially during debugging? For example, if I have date, Java date class, and if I have date also in my normal namespace in BB, is there something in the tooling itself to help make sure that I didn't use, for example, the Java version when I want to use the BB variable?
Okay, the question was how we distinguish between different types we are referring to that have the same name, for example. Yeah, one could probably provide a semantic highlighting, like using another color, or give information over the hover. I think the coloring would be the best match. Yeah.
Is there something implemented right now?
Semantic coloring, you mean?
No, I mean
Wise?
just to distinguish them.
No. Oh, yeah. The hover information, you can see if it's a Java class currently or if it's a function with a hover, yeah. But just looking on the code, it's not possible to see. No further questions? Yes.
Okay, then thanks very much.
Thank you for attending.